Welcome here, everybody. This is day 5 of CPR, and today's episode is brought to you by the Greek letter beta. Remember that some radioactive substances give off beta particles, which are electrons. And just a quick little demonstration for now. And what I have here is an air table. It's basically a small version of an air hockey table. I have it hooked to a vacuum cleaner via this hose over here. And the vacuum cleaner is running reverse, so it is blowing air into the table, and of course the air comes out through all the tiny little holes in the table, and whatever is on the table, as long as it's not too heavy, like these little pucks, they basically float on a cushion of air, so friction is pretty much negligible. And this is really good for illustrating the law of conservation of momentum. Now what I'm going to do when I turn the vacuum cleaner on, and of course when I turn the vacuum cleaner on, the only thing you'll be able to hear is the vacuum cleaner. I don't know, maybe that's preferable. But when the vacuum cleaner comes on and these things start hovering around, I'm going to take this one, which has a pretty small mass, and I'm going to give it some velocity and have it crash into this one, which has a much larger mass, and it is pretty much stationary. And well, see if you can predict what's going to happen and see if that actually happens. We'll give it a go. And of course, when they hit, the momentum of this one thing with a tiny little mass gets divided amongst, or gets distributed over an object that has a great big mass. And yeah, as you can see, the velocity goes right down. What do you think is going to happen if I do this? I give the heavy one some velocity, and it runs into the light one, which is stationary. Think about that for a sec. See if you can predict what's going to go on. See if you can predict how it's going to be different, similar yet different from the one we just did. Yeah, and as you can see, just like before, when the two come together, the velocity goes down. Doesn't go down as much because the mass that's getting added onto the moving one is quite a bit less, relatively speaking, than it was before. Anyway, hope you enjoyed that little demonstration, and pretty soon I will have some PDF solutions up for the vector nature of momentum assignment. Bye for now.